Good morning. This recording is for Algebra 1, Chapter 9, Lesson 8, using the discriminant. Remember that quadratic equations can have two, one, or no solutions, because a solution means the number of x-intercepts. To determine just the number of solutions, not what the solutions are, before solving the entire quadratic formula, we use the discriminant. And the discriminant is this lovely little short equation, or formula, b to the second power minus 4ac, and it might look very familiar because it's actually from within the quadratic formula. It's that. So if you have the quadratic formula memorized, you have the discriminant memorized, because the discriminant is basically the radicand, and the radicand is the stuff inside of a square root, which we're going to talk about a lot more in Chapter 10. Anyway, so if you plug in everything into the discriminant and you get a positive answer, basically something greater than 0, there's going to be two solutions. If you get a discriminant that equals 0, there's only one solution, and if you get a discriminant that equals a negative number, there's no solution. Okay? It's as easy as that. So if they ever ask you, is there one solution, two solutions, or no solutions, all you have to do is put it into standard, the quadratic equation that you're using into standard form, set it equal to 0, and then plug in b, a, and c into b squared minus 4 times a times c, and see if you get a positive number, 0, or negative answer. All right, so let's go ahead and use it. And again, that's determining factor, is basically if it's going to have two solutions, one solution, no solution. All right. So the first method is obviously the discriminant. We just got done talking about it. Basically anything set to 0, or if you just have y equaling, you can use the discriminant. So a equals 3, b equals 6, and c equals negative 7 for this particular example. And that would be y equals 3x squared plus 6x minus 7. So we're going to plug all this information into the discriminant. There it is. B is 6, a is 3, and c is negative 7. And we're going to get 36 minus 12 times negative 7, which ends up being 36 plus 84, which is a positive answer, which means there are two solutions. This parabola is going to hit the x-axis twice. Now, there's a way you can do it by factoring, though it's not very easy to see a no solution from a factoring situation, and it also kind of doesn't work if you can't factor something, but here would be an example of something that has two answers. That's a factored problem. All right, so that has two solutions. Here's an example that has one solution. And again, if it can't be factored, then you're going to have a hard time using this method to determine the number of solutions, but it's okay. The discriminant works every single time. All right, so let's apply this to a real-world situation, and I want to read this to you before I get into my lovely little graphic. All right, a construction worker on the ground tosses an apple to a fellow worker who is 20 feet above the ground. The starting height of the apple is 5 feet. Its initial upward velocity is 30 feet per second. Will the apple reach the second worker? So, here we go. Here's my guy on the ground with the apple. And there's my purple guy, who's my second worker, who's 20 feet above the ground. All right? The apple's going to take off, and it's going to fly up there, and it's going to come back down if the purple guy either doesn't catch it or it doesn't make it. All right? So, will it make it? I don't know. So, let's go ahead and talk about what this looks like if I were to put this on a graph. Well, the second dude, the purple dude, who's up on the ledge, he is basically where I want my x-axis to be, because I want to know if my parabola, the path of the apple, is actually going to hit where he is. Is it going to go above it? Is it going to hit it just barely? Or is it going to not make it at all? So if I make the ledge the x-axis, so because the x-intercept is where the apple's going to be, hopefully where it's going to end up where the dude is, right? I'm going to make that my x-axis, which means that's my y-axis. Which means that the guy throwing the apple down there at the bottom, he's really 20 feet below my purple guy. So he's negative 20 feet. So my ground is actually negative 20 feet because I really care about where my purple guy is, not necessarily where the apple is starting. But I do actually care about where my apple is starting because it was 5 feet above where the dude was who threw it. Right there. That's 5 feet above the ground. The ground just happens to be where the green guy at the bottom is standing. So really, the apple's getting thrown from negative 15 feet. That is the starting height. So this is actually going to become really clear when I actually plug it into my velocity motion formula, which is h equals negative 16t squared plus vt plus c, where v is the velocity, c is the initial height of my apple, and h is the final height. All right, and I want to know when my final height gets to 0, but I can actually start this out without even thinking about that, because my initial height, even if ground level was at 0, I can say I want it to get to 20 height, the height of 20, all right? So I can start it out this way too, where the final height is actually 20 feet and my initial height is 5 feet. Because when I actually solve this for 0, it's actually just moving it down. All right? So I can start my equation without actually having to factor in the fact that I am now making my guy throwing the apple below ground, or below, it's not even below ground, it's really just below the x-axis. All right? Because when I go ahead and solve this, you'll look, if I minus 20 on both sides, oh, and we're going to use the discriminant quadratic equation must equal 0. Right, so since it must equal 0, I'm going to minus 20 on both sides, and I'm basically getting what I just drew over here on the left. The fact that my initial height is actually negative 15. I've now just officially dropped where my dude is, that's throwing the apple, down negative 15 to see that if my apple's going to hit the x-axis, it's 15 feet above from where it started. Okay? All right, so we have this equation set up for what we want it to do. Now we need to figure out if the apple's going to make it. And again, the apple's going to make it if it can have 2 solutions or 1 solution. We'll just assume that the second guy is going to have to lean down a little bit to catch it. Because if it has 2 solutions, it means the apple's going to clear the ledge where the second dude is, and the second dude just needs to catch it. 1 solution means that the second dude's going to have to lean down a bit and get his arm right level with the ledge so that he can catch the apple. But no solution, well, that's just too dangerous, and he's not going to lunge for the apple because, you know, he might end up crashing to his death. So let's figure out how many solutions this has by plugging it into the discriminant. A equals negative 17, B equals 30, and C equals negative 15. So plug it in, and we're going to get a negative solution, which means there's no solution. Since the discriminant is negative, there is no solution, which means this apple is never going to hit the x-axis. It's not even going to go over the x-axis, which means this is not safe for this guy to catch this apple. So it's not going to happen. But, so now this apple's gone crashing to the ground, and there it is now. All right? He's like, ah, my apple! Well, it's really like my lunch. I don't have a lunch now. But, yeah. But let's say that the second guy goes and picks up the apple, and it might be a little bruised now, but we're going to try just throwing it a little harder. In this case, 32 feet per second, and we're going to see if now it will get up there. All right? We still don't know if it's going to get up there. And there's my apple, lovely drying itself as it goes in a beautiful arc. Will it make it this time? Now that the first guy at the bottom is now going to throw it at 32 feet per second. So let's go ahead and plug that into our equation. We're using the same equation, the only thing is we're throwing it a little faster. Instead of 30 feet per second, it's 32 feet per second. And basically everything else is the same. So let's go ahead and see if this apple will make it. Again, we're using the discriminant to see if the apple's going to make it. Again, we want a situation of 2 solutions or 1 solution. A no solution situation means the dude at the top, he's not going to get his apple. All right, so let's go ahead and use the discriminant. I'll throw it harder this time, and maybe it will get there. All right, so A still equals negative 16, because that's basically the force of gravity. B is 32, because that's the speed of the apple that the dude at the bottom is throwing it. And we still have a difference of 15 feet between the 2 guys. All right, so using the discriminant, plug everything in. Hey, and we get a positive situation, which means not only is the apple going to make it to the x-axis, it's going to go over the x-axis and come back. So hopefully the guy's going to be able to catch it and eat his apple. Since there's 2 solutions, the apple will clear the ledge, and hopefully the second guy will catch it. All right, that's it. Aren't you happy for a short video this time? All right, bye guys.